Natural Resources Canada. Oh, thank you, Claire. And then also posted in the chat there are the agenda and notes from the previous meetings. And just a note on the recording, we have permission from all the speakers to record this today. So this, once it's all wrapped up, this will be posted to the YouTube channel to go along with this. One other quick update before we hopefully get to our speaker. The Eielson Camp Reactor folks just sent out a quick update, a quarterly update. Part of that update, I think we heard from Corey last time, but part of the update that was new to me anyway was a better look at the projected timeline for the Eielson microreactor project. And so it looks like we're here in 2026. They are starting or have started the environmental investigations. The NEPA process is, if it has not been initiated, it will be soon. And they're also planning to begin the NRC application process. They're still targeting a completion, installation, and reactor running date of 2030 or so. And these are all, I'm not seeing exact timelines in the diagrams that they sent out, but sometime in 2030 is when they expect that reactor to be online at Eielson. So with that, I'm hoping it looks like Erin is on. And
my screen is, sorry guys.
Okay. Oh,
There we go.
catching up here. Okay, so we have Erin Robinson here today. Thank you, Claire.
Yes.
So Erin is with Nano Nuclear, and with that, I will hand it off. So Erin is a senior project manager. She works at the interface of corporate strategy and the techno development. And she'll be talking today about Nano Nuclear's reactor technology and their overall portfolio as well. So with that, Erin, thanks for joining us, and please take it away.
Yeah, thank you guys for the introduction. It's great to speak to all of you today about Nano. I'm really excited to be here and showcase what we're doing a little bit and why we're so interested in Alaska specifically. A little bit about me from my background, so you can see my education. Before this, I was at the Department of Energy as a project manager. So worked really closely with a lot of those NEPA evaluations, so very familiar with what you were mentioning, Jeremy. And prior to that, given my chemical engineering background, I was in the chemical industry for a while. So I've made a bit of an industry change recently by joining Nano. I can get into the slides next.
Yeah. Let me pull that up for you. Sorry about that.
Oh, no worries.
There we go.
Awesome, thank you. So Nano Nuclear Energy is a micromodular reactor developer. As you can see in this slide here, we are strategically vertically integrated. And what that means is, aside from just building the reactors, we are looking ahead at the risks in the industry, in the supply chain. And the main risk for all reactor developers right now, whether it's MMRs or SMRs, small modular reactors, is that fuel supply. So that's something that we're really focused on, is securing fuel and then also the transport of fuel. So we recently acquired STS. They're a well-established, well-known fuel transport company in the nuclear sphere. They actually transport for the Department of Energy. So again, very well-established, trusted by the government. So we're really excited to have them on. We have strong relations with fuel enrichers. That's one step in the fuel process that, again, is a big bottleneck for the industry. We can go to the next slide, actually. So we're a public company. There was something about the market validation on that slide. We're a public company, publicly traded, which sets us apart from a lot of other MMRs and SMR developers. Just in general, the US energy capacity versus demand, there's been, as you can see, we're in a transitionary period. So we've been seeing a lot more support for nuclear, but right now we're actually trying to make that happen with advanced nuclear. So advanced nuclear is these SMRs and MMRs, not the traditional light water reactors that you're used to, the giant chemical plants. Our MMRs only take up a couple acres, for example. and it's proven technology, but it is being newly deployed at a commercial scale. And so comparing to other clean energy alternatives, solar and wind have a lower capacity factor. They cannot produce the heat that is needed for a lot of manufacturing processes. Fuel cells are not as readily available. So when you look holistically at clean energy alternatives, looking at the capacity factor, the land footprint, the flexibility for different applications, and being able to power these various applications. So not just data centers, I think that's what a lot of people associate nuclear with. We can provide process heat to manufacturing facilities. We can go to the next slide. I'll talk about it more there. So I mentioned a little bit about large light water reactors versus micro reactors. But to distinguish between MMRs, so nanos, micro modular reactors, and some other companies in the industry that you might be hearing about a lot, often those are small modular reactors. So the difference is that we can build our reactors in a factory and then bring them to the site, so factory fabricate, whereas small modular reactors have to be built on site. We can be grid independent. That's a really big benefit for considering remote communities is a really big application there, but that is also can be something of interest for like chemical manufacturing facilities. I mentioned that's my background, or data centers. I mean, you can look at really anything that needs process heat. If I have anyone with any kind of engineering background, right, like any steel manufacturing, a lot of different applications. When it comes to the supply chain as well, aside from being grid independent, the supply chain for micromodular reactors has more flexibility than with those SMRs. And with the emergency planning zone, what that means is exactly what it sounds like, the zone that you have to plan within in the case of an emergency. Light water reactors zones is 10 miles. Microreactors are contained within the site boundary. What that means is that's within a couple acres. And that's including the nuclear plant and the supporting capabilities to connect into the system. For example, our flagship project is at the University of Illinois, Urbana-Champaign, and that is right in the middle of campus, right across the street from dorms. It's co-located to their power plant. It's called their Abbott Power Plant Facility. We can go to the next one. Thank you. When looking at power output, our Kronos micromodular reactor is 15 megawatts electric or 45 thermal. So the power comes out of the reactor at 660 degrees Celsius and then is put into our molten salt energy thermal storage tanks. And then the site can pull out as either electric or thermal power, whatever you need in that moment. It doesn't have to be set up differently based on what you need. I talked a bit about the 0 mile limited to the site boundary emergency planning zone. In addition to that, our reactors have a automatic shutdown and then passive cooling. The way the passive cooling works in the event of an emergency is essentially the way sweat cools you down. There's just a little pool of water that evaporates and cools down the reactor until it can be brought back online. And it totally stops operating. So with light water reactors, there are many human steps that need to happen to shut down the reactor. Our micromodular reactors automatically shut down. And the fuel cycle is 3 to 7 years. That depends on the enrichment of the fuel. I won't get too into all of that, but that can be flexible. This is just an example of deploying the reactors. Again, I won't go too into that. I think this is more applicable to specific sites, but we're looking at around 200 megawatt clusters. So that's 14 reactors. Most of the applications we're looking at are going to be much more than one reactor. I mentioned a little bit in the last slide about the coolant. I didn't mention that that is a helium coolant. It's a gas coolant. So our technology is high temperature gas cooled reactors, which some people are familiar with from Navy subs. If you have that background or are familiar with that, that's what those are. So that technology has been around for over 60 years, and it's been used for very small scale projects. So that's why when we're looking at these powering facilities and communities, there will be much more than one reactor in these situations. And I talked about factory fabrication. That means it's stackable and scalable. So it's very easy to build on and grow your power with your site as needed with these reactors. This includes a lot of information that I've already touched upon a little bit, so I don't want to be too repetitive. So talked about the process heat. I mentioned our molten salt thermal storage. So that enables load following. Essentially, you don't need to use the power as it comes out of the reactor. It's not use or lose. You can store that and pull that in as you need to your process. And I talked about being co-located. When it comes to deployment, we have a great team, a lot of NRC, Nuclear Regulatory Commission, ex-team members. I have worked very closely with them. I was the project manager on our construction permit application, which I believe is actually in the next slide. So we had our first milestone with our deployment project I mentioned at the University of Illinois, where we submitted our construction permit application to the NRC. For the nuclear licensing process, it's a very heavily regulated industry, which I, as a citizen, very much appreciate. It takes years to go through that process. It's very highly technical. It's very much an engagement between the company and the NRC representatives. So it's a partnership there. That's a huge milestone for the industry, for our company, and for our reactor technology. Some of the other points just outline a couple of our different projects. So showing that, we can work with military bases. I talked about remote communities. I've talked a lot about manufacturing processes. We're also partnering just for our testing and development with national labs. Our U of I site is our full-scale commercial technology. So we say prototype site because it is at a university as a research reactor, but it is at scale, and it is all the same exact technology that we'll be deploying commercially. You can go to the next slide. So I talked a little bit about how licensing is pretty involved. You can see here licensing regulatory is the bulk of the deployment timeline. That overlaps with on-site construction. So a lot of that construction is not just the nuclear components, that is the non-nuclear support as well. The final step that I haven't yet touched on much is fueling and commissioning. So putting the fuel into the reactor. I spoke about how the timeline is 3 to 7 months for refueling. So that will be a recurring step. It does not take much each time. That's just the initial fueling and commissioning and startup. It's a very heavily regulated and heavily trained industry. So again, I talked about how I came from the chemical field. In nuclear operator training it's very intensive. It's over a year long of training. So that's part of the process as well. So that human aspect, not just construction and regulatory. So we talked about energy density per acre a little bit when we compared some of the different types of energy. So this outlines a little more the total footprint based on numbers of reactors. For 1 unit, it's about 2 acres. For 4, it's 7. So it really doesn't take up much space when you're thinking of traditional nuclear. Again, talked about a lot of the use cases, but they're just listed out here, seeing how there's quite a wide range. It's not a niche specialty technology. It's not just connecting to the grid and being industrial power. It can really help with these remote communities, remote resorts, maritime applications, such as those Navy subs, even EVs. So powering other cleaner energy sources that we have. Looking at, a little non-intuitive petrochemical refineries. So we can help almost clean up our competitors' processes as well. The note about black start capability for defense, that is enabled by the fact that we can operate off grid. So we can just turn right on essentially with the flip of a switch. That's a bit oversimplified, but that's a key strength of the micro modular reactors that you don't see in some of those small modular reactors, and certainly not grid connected power sources or light water reactors. So our integrated solution, I spoke about how we're a vertically integrated company. Looking at the technology, what really is the main focus of MMRs is that they're just reliable. They will continue to power sites autonomously. It's the cleanest, most efficient energy source for energy in versus energy out. I've been in energy my whole career in different sectors, and I'm really excited to be in nuclear now because it really is the most efficient solution, the cleanest. I see it as the future. Obviously, I'm a little biased where I work now, but one note that I haven't talked much about, so I talked about our Kronos reactor for industrial capabilities for terrestrial on Earth. We have another reactor called the Loki reactor that people just think is kind of cool. It's a little less mature of a design, but there's a lot of overlap between the Kronos design that we're deploying at the University of Illinois. And that will be for space applications, so powering space missions. You see a lot about fission to surface power through NASA. So we're excited about that reactor. Certainly less commercial, but a nice, just exciting, interesting technology for humanity. I've already talked a bit about the fuel cycle, transportation, licensing. The one thing I've talked about with the fuel cycle is spent fuel. I understand that's a concern of communities. So with spent fuel, it's a very small amount. It's heavily regulated. We have such a strong team with our fuel transport company that we're really excited about to help manage that. The DOE Haleo Consortium is a fuel supply group, and the DOE and the NRC both are heavily involved with spent fuel storage as well. So that's really, again, encouraging to see that there's that regulation across the industry. And that is us. I mentioned we're a public company. So we're in New York. I'm in our New York office right now, but our deployment is happening all in Illinois at the University of Illinois. And our key technical team sits in Oak Brook, Illinois. We do travel all over, though. We certainly have remote people. And yeah, we're just really excited to be building what we're building. And that's all I have for you all today. So thank you for listening, and please let me know if there are any questions.
Thanks, Erin. Yeah, if there's questions, either put them in the chat or come off mute, and we'll try and get them answered for you.
Jeremy, I've got a question for Erin. This is Bill from AKNEWG.
Go ahead, Bill.
So you mentioned Loki, but you didn't say anything about Zeus, and we are a very small electric utility serving very small communities, much more interested in the nano nuclear solutions,
Yeah.
something that can be put into a container and shipped and those sorts of things. Can you give us an update on where that is in development?
Certainly. So first, I will answer the second part. So Kronos, our largest reactor, can be put in containers and shipped. So it's definitely bigger than Zeus, but it can power communities. Zeus would not be enough to do that. It's much less mature. We don't have, we're not even pursuing a flagship project yet. It's maybe more applicable for someone powering one house, whereas Kronos or Loki could be used for really small communities. But when I was talking about how many applications are going to need much more reactors, there's really none that would need less than one reactor. So I didn't mention that Loki is 1 megawatt electric or 3 thermal. So that's really small. But yeah, they can all be shipped in storage containers
Thanks,
Um,
Erin.
s- Yeah.
Looks like Nathan had his hand up, and then we'll go to Richard.
um,
Hey, thank you for the presentation.
Mhm.
Just a quick question on the fuel.
Mhm.
Do you guys feel like you have a line of sight on fuel, or do you have, the HALEU or LEU fuel on hand, and just so how much for deployment in the future? Just curious.
Yeah.
Thank you.
Absolutely, yeah. I also see a similar question in the chat. I'm not at liberty to disclose who our suppliers are, but I can say that we're evaluating a lot of different avenues. And specifically for our first project, since that's university, they can go through, there's a university fuel services program at the DOE, but for commercial applications, we're establishing longer term partnerships. I will say having our STS, the transport company, they have plenty of connections as well. So I know that's not the most direct answer that some people might want, but it's a highly proprietary topic.
Got it. Thank you.
Mm-hmm.
Thanks, Erin. Let's go to Richard, and then we'll try and address some of the comments or questions in the chat. Thanks.
Thank you. So, Erin, I know from U.S. Navy background, and Navy subs actually run the power down further than current boiling water or light water big reactors on land. That the power companies they run the reactor down to the point where the uranium still has about 85 to 80% power in it, which it seems to me absurd because they're so hot they got to put them in cooling ponds for 5 years. How far down are you guys able to run the uranium down before you have to refuel?
So the uranium goes in, so with the TRISO fuel that goes into the fuel, and there's different levels of enrichment. So there's the LEU plus and the HALEU plus, or just HALEU, excuse me. The reason I had the range in the years of refueling is that our reactor can use the LEU plus. Many of our competitors can only use HALEU, but there's a big bottleneck for that right now. So we designed it so that we can take either one at this time initially, just so that we can get fuel and get projects started. And yes, we'll have to refuel after 3 years rather than 7 for those first projects, but it's better than holding off the project while we get fuel. When it comes to the actual percentages, I don't know exactly with the refueling, like after the fuel lifetime, what that percentage is in the reactor. But for enrichment of the fuel supply, the LEU can go up to about 9.75%, while the HALEU can go up to 19%. And then above that, you get into weapons grade. So we certainly don't want to deal with weapons grade fuel levels.
Yeah, so it seems like you're running them down further than the big commercial plants, and probably on par with U.S. Navy reactors. It's still disappointing. We're dealing with phase changes. We're boiling water to create steam and all that stuff. But it's still
Okay.
and it's very promising. I'm really support what you guys are doing.
Yeah.
But I'm concerned about we're not using the uranium that much. We're using it for a few years, and it's still hot. It's still very radioactive, and it's. I was hoping that the new micro reactors would be able to extract more of that energy.
Okay, yeah. So let me speak a little bit to that. So for the coolant, we use helium coolant, so we do not use water. We do not use water coolant at all. I mentioned that we have a little bit of water for emergencies to just evaporate off. When it comes to the coolant, we don't need to put the spent fuel into pools to cool down. We plan to use just dry casks, so just put it in concrete, bolt it shut, let it cool down. We don't need those pools. I can't necessarily speak to competitors designed for that because, again, that can get we're still a bit early stage for a lot of these projects.
Well,
But we
that's
definitely
good.
don't need that
That's
level
good
of
news
water.
right there. You know, that's that you're going right into dry casks. That, you know, this is mathematically calculated, you know, physics, how much energy it has. And, you know, that's where the percentages come up. But from the mere fact that you're putting them into a dry cask, that I'm excited.
Great.
That's an improvement.
Yeah, no, I'm glad. Yeah, I didn't necessarily know everyone's background in this call, so that's great to hear. We have a lot of ex-Navy nukes at our company, and they're very wise people. I'm sure they could speak a little more about where your questions are coming from. If you want to get my email, I can definitely get you in touch.
Erin, is that true for everyone using the TRISO fuel that they don't need to sort in water?
Not necessarily. I am not in a technical role here. I know exactly who to talk to at our company to get you in touch with that. But again, I think that's a very internal business decision that people have not necessarily released publicly. So it's really difficult to say what competitors are doing there.
Okay, thank you.
Mm-hmm.
So a couple of comments in the chat. One, Tony points out that a lot of Alaska remote communities have average loads below 1 megawatt. So, so that the smaller reactor might be of interest. But then a couple of questions there. Jay asks, have any Alaskan communities or tribal organizations expressed an interest in SMRs or MMRs? And then David asks, what's the projected cost per kilowatt hour for power?
Yeah. Thank you, Tony. That's really helpful background. I'm certainly going to look into that. I think that some of what we were thinking was larger reactors to potentially power multiple communities, but I understand with transmission lines how all of that can add up to cost. So that's something I'm going to take back to look into when we look at our remote community use cases. But unfortunately, we do have the focus of Kronos, Loki, and then Zeus. Just at this time, we have had this kind of feeds into Jay's question. We have had some initial interactions with Alaskan communities, and there is definitely interest, not in the immediate future right now, though I wish there was. I would love an excuse to get to visit Alaska a bunch. It's my favorite state I've been to, and I've been to 48. And there is interest. I think when you talk about the technology, just how reliable it is, that is obviously really important to tribal and remote communities. When it comes to the reliance on diesel, it's my understanding that Alaska is actually maybe the only place where the financial model makes more sense to have these MMRs, because you have to fly out the diesel, which is that's got to be extremely inefficient in some cases, is what I've been informed. Please correct me if that's misinformed. So in short, yes, there's interest. There is not right now a clear pathway to powering those communities. And I will be part of this. We'll continue to engage and try to understand how to make that happen if there is genuine interest from those communities. When it comes to the projected cost per kilowatt hour, that's highly dependent on so many factors that each individual site is going to be heavily involved in those decisions. The first step before we deploy a reactor is a feasibility study of the site, and that begins to inform some of the costs. So it's very civil heavy, looking at the type of land. For example, we looked at a project in Texas that they essentially want to build on almost like quicksand. That's going to raise the costs, and that's completely not nuclear related. That's just building related. So when you look at the initial deployment costs and then try to calculate out the levelized cost of electricity, that there's so many factors that goes into it. The fuel enrichment level that we talked about. The fuel is honestly the most expensive part. That's a recurring cost. Once you initially have the build out, it's pretty smooth sailing from there, from the reactor standpoint. But just to give you some more background as well, the metals that go into this need to be nuclear grade. These sites need to be it's NQA1 specifically qualified, that makes it more expensive. You can't just go to your standard steel provider. Depends how many projects we have at the time, how, the more you buy, the less it is per ton. So that's dependent as well. I'm not trying to avoid giving you a number. I'm just telling you what goes into it and why I do not have a number for that specific use case. But I can say that from what we've seen, Alaska remote communities is one of the places where it makes sense financially right now, whereas a lot of places, their main concern is reliability over the finance making sense on its own.
Thanks, Erin. So I understand Ryan has just got on the ground, so we'll switch a little bit to the roundtable, I think, if there's no further questions for Erin. I'm just trying to watch.
I don't see any, but thank you, everyone. Those are really great questions. Please feel free to get my email from Claire and reach out with any follow-ups or schedule any further discussions. Thank you, Jeremy.
Thanks, Erin. So yeah, I guess wanted to let you know what's coming up this summer. So right now we have on July 25th, looks like we have Adrian Schweer, Head of Government Affairs for Oklo, will be with us on the 25th. August speaker is still TBD. I will note about August, there are a number of meetings happening at the end of August, which is, I think, probably when this would normally be scheduled, including the Alaska Defense Forum, which is here in Fairbanks. So we're still trying to pin down the agenda and speakers for that, but I'm sure there will be some nuclear-related topics that are talked about there as well. But for now, August speaker is TBD for the Alaska Nuclear Working Group. And then again, on July 25th, we should be hearing from Oklo. I do want to put it out there for folks, if there's, thanks for putting that, Claire, for the slide up there, Claire. Are there things you would like to hear about in the future? And then are there people or topics that are of interest to you? If you've got strong feelings about that, you're welcome to come off mic and request that we try and reach out to folks. Or if you want to just put it in the chat, we can collect those and then take that as feedback. So if there's folks you want to hear from, reactor developers, folks from DOE, updates on specific projects, please let us know. And given that we just heard from NRCan, Natural Resources Canada, maybe that would be a next logical speaker to hear about what the Canadians are up to. Let's see, I'm not seeing anything in the chat. Very quiet. So I will take that as everybody, you're getting all the information you could possibly want. Oh, Richard, looks like you came off mic. So
Yeah. Yeah. Glad to see Oklo is going to give a presentation. But I had a chance to talk to some of the guys at Westinghouse for their Da Vinci reactor. Be nice if we could reach out to Westinghouse. They're the big guys. They built reactors for the U.S. Navy for a long time. So I'd be curious as to their approach to small modular reactors or microreactors.
Yep, absolutely. And a lot of the folks who are on the call have heard quite a lot from Westinghouse, but not lately. So that would be a good update to get. And there's actually a Canadian connection there as well, because SRC in Saskatchewan was supposed to be a partner on an early Westinghouse deployment of that eVinci reactor. I don't know the current status of that. Okay, we've got a chat from Ara indicating Westinghouse might have actually pulled out of the market with the eVinci. But maybe we can do some reach out on the back end, Claire, you, me, Nicole, and see if we get some confirmation there, or if we can just get Westinghouse to give us an update straight from the horse's mouth. Yes,
Yeah,
and Nicole, your point taken, they were pretty strong focus on defense applications for Westinghouse.
Mhm.
I'll also note potential for Jeff Waxman to give an update on the Project Janus at the Defense Forum. We're trying to get confirmation that whether he will be able to make that, though. And Project Janus, for those of you who are not tracking, is the Army advanced reactor effort that's sort of running in parallel or maybe faster track than the Eielson reactor. And Fort Wainwright here in Fairbanks is on the short list for a potential microreactor deployment as part of that Project Janus. And there's a number, I think there's about 9 to 12 sites around the country that are on that short list. And Jeff, I think we've heard from him at this working group, but Jeff is the lead for the Army of that Project Janus. Okay, and Ara, a little bit more information on Westinghouse. I guess INL or Westinghouse was supposed to go to the Dome facility at INL, but they've canceled their residency. Okay, Claire, I wanted to do a quick time check. Would now be a good time to get Mike
I
on?
am still waiting. Unfortunately, I think it sounds like Ryan's plane was late.
Okay.
I don't know, Mike, if you want to hop on and speak for a few minutes.
Sure.
I've given Dr. Bahran basically an open invitation. I know he's a very busy man, so we are hopeful that he joins us today. But maybe you have a moment to speak about it. We'll see if he can find a quiet place.
Sure. Well, I feel honored and a little humbled stepping in for Dr. Baran, who, in addition to being Deputy Assistant Secretary for Nuclear Reactors, has worked at Los Alamos and the Nuclear Regulatory Commission and the Department of War, among other places. But what I think he would say, but in greater detail, is that this is an amazing year for nuclear technology. We've had multiple new reactor startups go critical before the 4th of July deadline that was established by the department last year. And under the leadership of Secretary Wright and Assistant Secretary Garish and Undersecretary Houstveit, the department is committed to finding applications for nuclear power in Alaska and across the Arctic. I know I've met with many of your communities and organizations, but we'll have several senior DOE visitors to the state over the next couple months, and not from probably. Well, we'll have several senior visitors, and if there are opportunities or people who want to discuss the potential for nuclear in their community, please reach out to me. We would certainly entertain that interest and put you in touch with the right people, whether it's Dr. Baran or with others. So a great time for this. Sorry about this schedule snafu, but that seems to be the theme for this month. Next month will be the month for punctuality across the board. This month has been a little crazy for everybody, I think. So I'll give back the time to Jeremy and Claire, but please reach out to me. Please reach out to me, if there's specific interest we can help put you in touch with. Thanks.
Thanks, Mike. And speaking of busy schedules, our usual host, Gwen Holdman, ASIP's chief scientist, is actually at PNNL this week. So she's working on her podcast, Closing the Gap, and doing some recordings at PNNL. So related to nuclear. So she's got a good excuse for not being able to make it today. She sends her regrets. And then Nicole, thank you for putting the link in there about Project Janus updates. Looks like there were 9 sites as part of that Project Janus. So I'm sure we'll be hearing more about that as we get closer to, down select for the sites and then selection of reactor technology and all those great details. With that, I think, Claire, should we go ahead and
Well,
wrap up? Or
I was gonna ask the group. I mean, I I really know that we've been trying to get Dr. Bahran on here. I was given the impression that he will be joining as soon as he's able. So, if you guys want to hang out, until he can get here, I'm open to that. It's sort of up to the group's feeling here.
We could put maybe a timestamp on it, Claire, if we want to give an additional 5 to 10 minutes. And if folks want to use this time either to pose some general discussion questions or if there's specific speakers, I loved hearing interest in Westinghouse. If there are other topics that folks are keen to hear from, we are working on getting someone from Canada to talk about the major strides that they're taking in advancing microreactors. Are there other countries folks are interested in hearing from or other specific topics? You can drop them in the chat or go ahead and pop on screen.
We do have someone that we're trying to line up in France. There's a spent fuel recycling company that we've reached out to. We have someone from Eurotech Ventures that is related to Steady Energy in Finland. So they're sort of like sister companies, is my understanding. I'm still feeling that out. Let's see. Yeah, those are the ones that we've sort of been reaching out to and having early conversations with, but we definitely would love to hear whatever you guys are interested in.
And one thing, it looks like Jean asked for some clarification. I said the 25th for Oklo, and then the slide said the 28th. So
I see that, and let me double check.
And I assume this will be on
It is the
Tuesday.
28th.
Okay,
Yeah,
Tuesday the 28th.
It is the 28th.
So, yep.
Apologies. Sorry, guys.
Thanks, Jean, for asking that. So the next one with Oklo is on July 28th. Claire's slide was right. Okay. And then Bill asked, is there a present list of nuclear tech that has gone critical before July 4th? I think Mike might be able to answer that question, but definitely Ryan would have that answer very quickly.
Repeat the question, Jeremy. Sorry.
The reactors that have gone critical before the July 4th deadline.
Oh, we put out a press release. Yeah, I think one was Antares, and I apologize. I can find out and get it to you very soon. We put out press releases on the DOE website, but I do not recall off the top of my head. I apologize if it was your company and you're on here, speak up.
It looks like Quinlan indicated Belair.
That sounds right. Yes.
Okay. And Nicole, if you can track down that press release, we could put that in the chat too. Okay. Thanks, Quinlan. You got it. So link to that press release in the chat there. And then Ness indicates like to learn about uranium demand and mining. And I guess maybe if Nicole or Carolyn or Claire, can you remind me, there was a little bit of discussion about about using more of the reactor fuel. Did we hear from DOE on fuel recycling as part of this? Or is that something we should get some
No,
further
it was
information on?
economically not quite feasible, so they didn't discuss it at the time, but we did want to bring outside sources who actually do it because that is a big discussion point.
Yeah.
I think that was related to us looking into this company in France that does the fuel recycling because
Okay.
we're hoping to be able to find someone there since they've done it.
Great. Yep. And I know that's
The company is called I can drop their website. It's called Orano. I don't know exactly how to pronounce it, but I'll drop their website in the chat here.
Thanks. And I think this group probably knows this better than I do, but the way I break it out, there's kind of two parallel tracks that DOE is pursuing right now. There's their actual new reactor tech track, and then there's the fuels line development simultaneously. Part of that fuel line development is that recycling of the fuel and using more of the fuel than or using as much as possible. So yeah, seems like that would be a good, if we can get the information from this French company and then maybe a
I think
speaker from DOE on that
I want to say
parallel
Gwen was
process.
able to visit them when she was there. So our hope is that her connection in France is able to get us someone.
Yeah, that'd be a great discussion to have.
Mhm.
Yep,
And then
and Sherry
for
points out, oh, go ahead,
for
Nicole.
uranium mining, Canada would be a great example again, going back to the Canadian because they've been doing it for years and years and years.
Yes, and I think that was mentioned in that press release there.
It says, yeah.
Saskatchewan produces look like 100% of Canada's fuel, and I'm guessing that they're probably one of our suppliers as well. So that would be maybe good to get more information from NRCan or from maybe some of the miners that are and reprocessors. So very happy to have Dr. Rian Bahran here, Deputy Assistant Secretary for Nuclear Reactors with U.S. Department of Energy. Unlike a lot of us who are not subject matter experts in nuclear, Dr. Bahran actually has a PhD as well as a bachelor's degree in nuclear science and engineering. So, Dr. Bahran, thanks for joining us. And I believe we're going to hear not so much slides, but just a quick overview of DOE priorities and what you're thinking about these days. So thanks for joining us.
Great, thank you, everybody. It really is a pleasure to be speaking to you all. It's a really exciting time for nuclear energy, and I'll say, for some of the areas of my portfolio, specifically microreactors, Alaska was actually at the forefront. I mean, the first announcement of a deployment of a microreactor for a military installation, happened at Eielson Air Force Base under the Air Force, and so that, to my perspective, broke the glass ceiling about, we are ready to start thinking about deploying, small advanced modular reactors, microreactors, in the United States and certainly in areas where they need it the most. So thank you all for being kind of early champions of this technology. It's been an incredible year and a half. So the president signed, 4 executive orders May of last year, and they do a lot and they say a lot, and we really in the Department of Energy have been focused on the implementation of those executive orders. They set out the policy. It was clear. We need to make sure that we really usher in a nuclear renaissance, right? The idea of accelerating deployment of all sorts of nuclear technologies. So I mentioned microreactors, which is kind of a favorite, but it includes microreactors, larger scale SMRs, including Generation 3 Plus and Generation 4, and gigawatt scale reactors. And the goal is simple, how do we make sure that we meet the load growth? There is demand for energy in this country for the first time in a long time. And part of that is driven by artificial intelligence. And so I'll talk about some of the work that we're doing to advance nuclear to support energy, but we're also equally excited about applications. That includes, supporting space and defense applications, whether it's military installations or NASA's recent announcements about getting a reactor to Mars by 2028 and on the moon by 2030. So our goal is to really, make sure through our kind of a technology forward approach, through a lot of different tools that we have in the department, to get this technology ready. And I'll tell you, with the policy direction and support from this administration, the technology is ready, the regulatory framework is ready, and it is time to deploy. So I think my goal will be to walk you through some of our kind of major initiatives and programs that are in our office, and I'm happy to take questions from the group. Let me start with gigawatt scale reactors. There was actually an announcement today. The department put out a conditional loan commitment to deploy 10 gigawatt scale Westinghouse AP1000 reactors in the United States. This is the goal of this funding is really to order long lead items, which will accelerate the deployment of 10 reactors by at least 3 years. So this is a big deal. We've been excited about the need to deploy gigawatt scale reactors in the country, but we haven't had much movement. And this is a huge, I would say, push by the administration in close coordination, of course, with utilities. So really exciting, and you'll see the headlines all over. This is a serious step towards large-scale gigawatt-scale deployment, and we need gigawatt-scale centers. If you look at the load growth and how much energy is needed in this country, the executive order that the president signed said 400 gigawatts by 2050. It also says, at least start construction on 10 gigawatt scale reactors within the next, 5 to 10 years. And I know that sounds like a lot, but if you think about 400 gigawatts by 2050, 10 gigawatts is just one thing that we need to do from a gigawatt scale. We need to be pushing for SMRs. We need to be pushing for micro reactors because there's a lot of energy to help solve for. So that's one big push, and the energy dominance financing, which is I joke it's the artist formerly known as LPO, the Loan Program Office. They're the ones that have led the due diligence associated with crafting this big push on scale. That happened today. Let me tell you what's happened in the last week. So I'm going to jump scale to micro because the first time in over 4 years is a non-water reactor. I was it was entire one of the 11 projects, one of 10 companies that were accepted into the DOE's reactor pilot program last year. So executive order said 10 large-scale reactors, but then it said, turn on at least 3 advanced reactors under a DOE pilot program where we use our authority to provide, the equivalent of licensing for companies that are looking to test an advanced reactor concept. So we haven't done this in 40 years in terms of privately funded, and Antares was the first to turn on. They went from concept to turning on a micro reactor in under 10 months. It was incredible. And shortly the kind of week after just on reactors as well, high temperature. We're still by July 4th. That was the goal set in the executive order, and we're hopefully going to have more than that by the end of July. The point is, under DOE's authority, these companies have been able to go through technical and regulatory milestones, and they've been able to kind of prove, not just to the public, but equally important to their investors that unlocks private capital, that they can build hardware, that they're not stuck in kind of a regulatory, kind of an endless kind of regulatory paperwork process. They're building hardware, they're testing reactors. These are prototypes of hopefully in the future commercial variants, but they're able to do it at a pace that we've never seen before. So these companies are turning on reactors, they're unlocking the private capital that's needed to generate more hardware and build further prototypes so that they can deploy at places like Alaska. So really, really exciting. In addition to deploying under DOE's authority, we've been working closely with the Nuclear Regulatory Commission to ensure that what they're doing under our programs is providing them a fast track to a commercial license. So the way we're doing that is DOE, NRC actually has detailees that are part of the review processes for these reactor concepts. And in addition, NRC and DOE, we've updated our MOU with an addendum that codifies, how this relationship, by making sure that what we're doing is not being duplicated through the NRC. That's being codified not just in an MOU addendum. NRC put out an internal guidance memo to the staff that clarifies the roles and responsibilities. And there's draft rulemaking right now. And the goal is quite simple. How do we take advantage of the incredible and important technical work that DOE as an independent federal regulator is doing to fast track to a commercial license? So really exciting work there. This has gone so well that we are now, we've announced a few months ago, the successor to this reactor pilot program called Launchpad. And the idea here is now that we have this muscle, the DOE, is able to flex this muscle of its own authority to exercise, offering companies an opportunity to, under DOE's authorization, quickly turn on with their funding. By the way, we didn't use any taxpayer money. We're just providing authorization and support services, by providing kind of a concierge level service to ensure that we can remove, hurdles associated with testing. So Launchpad provides the ability to test at Idaho National Laboratory, which is our kind of premier multidisciplinary, but primarily nuclear energy laboratory, or outside of Idaho National Laboratory under Launchpad USA. And we're expecting to get a tremendous amount of applications. It closes on July 8th. And it's not just true for reactors. We've expanded this for fuel cycle facilities as well. That includes fuel fabrication, enrichment, reprocessing. We set up a fuel pilot line under the reactor pilot program, and the goal was simple. One of these reactors, at least one of them, required TRISO fuel, and we didn't have enough capacity in the United States. And so we provided authorization to Standard Nuclear, which is the first company to get DOE authorization, and they've been ramping up their production to support one of our test reactors. So it's an exciting, exciting way that the Department of Energy has been able to enable industry to put their capital at risk to go through these technical regulatory milestones and turn on reactors. It's creating a lot of excitement that's bleeding its way across the board that, we can do hard things. Now, in addition to the pilot program and Launchpad USA, we are looking at other ways that the department can support industries. And so we put out multiple RFIs for taking advantage of our federal lands, looking to entice applications related to energy generation and data centers to be able to, again, use our federal lands. And it doesn't have to be under DOE authorization, certainly can pursue an NRC license. But, there is a suitability assessment that we've done. And we find that many of the DOE laboratories, are well cited and well characterized and offer potential, avenues for that type of a proposal. So we've done that for Idaho National Laboratory, for Savannah River, for a few others, and looking forward to announcements on that by the end of the year. In addition to federal lands authorization, the loan program, we do offer quite a few different grant programs within the Department of Energy. Our probably big marquee ones is our Advanced Reactor Demonstration Program. This is where, through a public-private partnership, we're working with companies like AKNEWG and TerraPower to cost share demonstrations of their commercial scale reactors. And this is for TerraPower, the Natrium reactor in Wyoming, and for AKNEWG, their reactor, the XC100 in Seadrift, Texas. So this is really, really exciting because these are large-scale SMRs, high-temperature gas reactor, a sodium-cooled fast reactor, and these are intended to not just provide electricity, but also offer versatile attributes from a process heat perspective or from a energy storage perspective that opens up application space. So, for example, AKNEWG is working very closely with Dow Chemical for their deployment to provide both electricity and process heat for a major industrial player for a major industrial process. In addition, we're working with Kairos, and Kairos really was one of the early companies that was looking at doing iterative testing with hardware, non-nuclear engineering test units. But they were doing that, before I would say it was cool. And so they're an exciting company. We've awarded them a risk reduction award. All three of these companies are working with hyperscalers, ensuring that they're getting offtake and commitments, from companies like Amazon and Google and Microsoft to support, their future deployments. So the government's coming in with these grants, public-private partnerships to get these reactors built. In addition to the air announced award to TVA for building the GE BWX-300 at Clinch River site in Tennessee, and we provided an award to Holtec as well for deploying their SMR in Michigan. These are each $400 million awards, and the goal is simple: how do we unlock fleet-level deployment by de-risking the first deployment? And so it's an incredible program. And Gen 3 Plus are important technologies because their supply chain, they're just shrunken versions of the current fleet, so their supply chains are quite mature, and we think we can accelerate deployment there. We've also worked with NuScale in the past, where they're one of the kind of furthest along on the regulatory side of the house. So a lot of excitement about Gen 3 Plus technologies. We also released a supply chain award under the Gen 3 Plus program, about $94 million, that went to different parts of the Gen 3 Plus supply chain, from things to forgings, to fuel pieces. But we also are supporting some of the early de-risking by funding early site permits for these deployments. So exciting work there on the grant side of the house. We also steward and continue to steward the R&D programs. And a lot of that work is done at the national laboratories. That's work that helps all the companies, right? I mean, these technologies, even if we're in the deployment phase, are still being improved. They're being optimized. We have a light water reactor sustainability program, which is now pivoted to we call it the Reactor Power Optimization Program, the Power Reactor Optimization Program. The idea there is, how do we do R&D to get everything that we can from the current fleet And that R&D includes supply chain analysis, techno-economic analysis, and even kind of different ways that reduce the costs of maintenance and operations. A lot of work on the artificial intelligence side of the house there. And we have taken that work and we've actually brought it up a level and said, hey, look, we actually believe that there's a lot more that we can do out of the current fleet. And so we launched Uprise, which is a new initiative intended to meet a challenge from the executive order that said we should be able to get 5 gigawatts of new nuclear out of the current fleet. So it's really new nuclear capacity out of the current fleet. And so this initiative takes all of that great technical work. It works with both the end users, which would be hyperscalers that would want offtake, and it works with the utilities, and it works with vendors to find ways to get to that 5 gigawatt target. The Department of Energy, we actually decided to surpass that target. We're aiming for 2.5 gigawatts of new nuclear capacity from the current fleet by 27 and 5 by 2029. And we believe that you can get super uprates from things like fuel advancements in the current fleet in the 2030s. So a lot of push there on the current fleet, but that R&D also continues for fast reactors, high temperature gas reactors, molten salt reactors, microreactors, a lot of incredible R&D that's going to uplift the future fleets of advanced reactor technologies. I'm excited about that work there. One of the cross-cutting R&D areas that we are doing that helps everybody is on AI. I am truly a believer. I use frontier models extensively. And our vision in the Office of Nuclear Energy, which actually aligns with the vision of the Department of Energy under the Genesis mission, is how do we take advantage of AI? Frontier models, not just to uplift, not just, hey, Copilot helping me write an email, but to transform how we do nuclear reactor design, licensing, manufacturing, construction, and operation, and the R&D as well. And so the way to do that is think about agentized workflows. I have AI agents that are working across the board, ensuring the cross contamination. I call it cross contamination, but AI agents that work on the licensing for a reactor are the same ones that are supporting the manufacturing and the construction. So this full kind of ecosystem that's transformative. We've piloted a few examples here where we were able to go within just a few weeks, go from a concept to a 3D printed part that we put inside of a reactor test for one of these pilot programs. We've taken things on the licensing side of the house where we've taken a chapter that's taken 6 weeks to provide a kind of an application for a DOE authorization. We've shortened that into hours. So the level of improvements we're seeing at the pilot level are incredible, and we're hoping that with a focused approach where the sum is more in the parts, that we can actually have transformational investments in this area. So the Genesis mission at the Department of Energy does this for multiple parts of the department's mission. So not just nuclear, but hydrocarbons. It does it for critical minerals. It does it for basic science, high energy physics, biology. It also does it for the national security mission. So we're doing this under the Genesis mission. We put out a request for applications of $293 million to tackle at least 20 major challenges, including this nuclear one that I articulated. So we're quite excited about that work. It's a huge, there's huge potential for uplift. I'll talk a little bit about the microreactor program. Within that program, we do have quite a few different R&D technology maturation elements that we do. One of them is actually under the Marvel reactor. We have our own test bed, and there, although we're turning on these advanced reactors for industry, the Marvel test bed is looking to accelerate how do we think about integration between nuclear reactors and things like data centers. Because it's easy to hand wave and say, look, resilient, reliable, clean energy, let's just put a data center there. But this is still, it still requires R&D. This is still technology development, and so a lot of important work on Marvel. And I'll end by just talking about two things that are not directly in my portfolio, but important to the office. One of them is on the fuel cycle side of the house. A lot of the advanced reactors require high assay, low enriched uranium, and certainly all of them require uranium, including LEU. And so the Department of Energy has made major investments, $2.7 billion to really accelerate the ability to be able to meet the demand from nuclear deployment. And we're not stopping there. We're supporting enrichment, but we are also thinking about conversion and fuel fabrication. and we're looking at reprocessing. We think that used fuel, there's plenty of good material in there. As a nuclear engineer, the first time I learned about, nuclear reactors, I heard, here's what goes into a reactor, here's what comes out, here's how much energy is still in there. And so we're, as a matter of policy and program, tapping into that. So a lot of exciting work there. Um, and then finally, we put out RFIs for this for these nuclear life cycle innovation campuses, and the idea there is simple: that by looking to unlock parts of the supply chain, parts of the nuclear life cycle, including if we want to take what's in the used nuclear fuel and do reprocessing, fuel fabrication, power reactors, co-located with data centers, that's an incredible ecosystem that offers some incredible economic prosperity opportunities to states. And so we've had over 20 states raise their hands saying that they're interested, including a handful of states that are really, committed to taking on this opportunity of exploring this entire life cycle innovation. And that includes, taking disposition of the used nuclear fuel and gaining the advantages that would come by co-locating all of those different elements. So really exciting work there. And I think I'll end there. I'm happy to take any questions, and I appreciate Alaska. Our microreactor federal program manager, sits on multiple working groups. Our goal is to support both the state, to support our Department of War as they think about their deployment opportunities there, to support our industrial partners that look for industrial applications in Alaska, and more importantly, to support the average American that lives in Alaska with energy affordability. So I think our goal is to use every tool that we can to enhance energy affordability, to advance this technology. And we're just grateful that Alaska is kind of one of the early movers in this space. Thank you.
Thanks, Dr. Bahran. So yeah, I'll just do a quick summary. We heard about a lot there. So I think last thing we heard about state partnerships, that nuclear campus RFI, which Alaska did respond to. Heard about AI, heard about DOE and NRC working together on smoothing and lessons learned and not duplicating efforts there on the permitting side of things, energy dominance financing, large-scale reactors all the way down to the microreactors. We heard about public-private partnerships there. Heard a little bit about fuel lines development, future fleet R&D type activities as well. So overall, it sounds like DOE has and then finally improving the existing fleet as well. So a lot of ground to cover. So I appreciate that. And if there's questions folks have for Dr. Bahran, please place them in the chat, or maybe chat is the easiest, but if there's folks who want to just come off mic, we can do that as well. It's a quiet audience today, so I guess one question I had there on the life cycle campus, what are the next steps there? That first step was an RFI, I believe. Is there going to be a funding opportunity that comes out of that, or is it some different new type of process, or what can we expect there?
Hey, thank you for that question. I know that my leadership, is in close discussions with different states. This is intended to be a voluntary federal-state partnership, and so I won't get ahead of those negotiations. But I will say it's just quite exciting to see states raise their hand, kind of interested in this opportunity. I think it's one of the actions from this administration that's going to be an entire uplift to the whole community.
Thanks. Yep. And I just should emphasize that was the states responded to that RFI. So
So
it's
I see a
definitely a
question in the
negotiation.
chat.
Yeah,
Go
I was
ahead.
going to say, I do see a question in the chat from Sherry regarding the integration of AI assistance in licensing and operations. How is the DOE balancing the speed of AI-driven reviews with the need to prevent black box anomalies in safety critical nuclear software systems?
It's an important question. I think when we think about licensing, when we think about autonomous operations, anything that has a safety critical element, verification, validation, this is at the forefront of our minds. We are still kind of on the accelerating the R&D piece of this. And And so for us, I think, I make a good example that, I mean, people are often skeptical about AI because they say, well, I've used frontier models and they hallucinate. And I always joke, well, if I pulled somebody off of, just out of the grocery store and asked them about safety, nuclear safety things, they would probably hallucinate as well. And so it's important to, both train and ground these models. And there's really both there's a science to do that, and we have some of the best experts that are looking to do this for a lot of applications where ensuring that there will be predictability, transparency, and an understanding of what goes into these processes. And of course, that applies for both the applicant on the licensing side of the house or the regulator that's using this tool for the reviews. I see a different question on how do we establishing to ensure the human in the loop oversight remains absolute and isn't compromised by automated efficiency. I mean, I think for us, we've been, quite clear that, we will always have humans in the loop. And so that's kind of our commitment. We're not looking for a fully 100% AI autonomous, reactor. There's no need for that. I think what we're looking for, is to take advantage of these frontier models and capabilities. And certainly, if we can increase the commercial viability for advanced reactors, including microreactors, that may not require the same amount of operators or guns, guards, and gates, or whatever physical human footprint that is needed. But we will always have humans in the loop. I think that's going to be an important commitment, not just by the Department of Energy, but certainly by the industry.
Thanks. And just to follow up on that, you mentioned Project Genesis as that's one of the large scale efforts that is trying to advance use of AI in multiple fields. Is Project Genesis one of the efforts that you're using to advance this question that Sherry is asking about?
Yes, the Genesis mission is really kind of the overarching umbrella that includes over 20 different SNC challenge problems that are national challenge problems. One of them is actually the title of it is accelerating nuclear deployment that is cheaper, safer, and faster. And so we have safer in there. We have that on purpose because I think for us, as we think about AI to accelerate this licensing, so design, licensing, operation, manufacturing, and construction, we actually think that AI is not just an opportunity to accelerate our ability to do these things, but can actually add safety, right? Again, if it's done in the right way. And I see one more question with rapid deployment timelines. How's the department ensuring that local municipalities and first responders are adequately trained and equipped to handle the unique physics and hazards of advanced reactor designs before they arrive in their communities? Well, one of the good things about a lot of the advanced reactors that we are supporting is by definition, because they are advanced reactor concepts, the kind of credible abnormal conditions and hazards, the kind of their worst case scenarios, really have been well studied and characterized and have allowed both the regulator, whether it's the Nuclear Regulatory Commission or the DOE, to consider emergency planning zones that are much smaller, that are at the site boundary. So, already these advanced designs put less pressure on local municipalities to have first responders to have broader coverage. So that's point number one. I think point number two, a lot of these advanced reactor concepts, they're credible abnormal conditions, even the hazards that could occur at the site boundary or within the site boundary, are again well characterized, well understood, and are because of the nature of some of the, not just reactor designs, but let's take an example, TRISO fuel, right? The TRISO fuel itself, each TRISO pellet is a containment vessel. So in an abnormal accident situation, those individual pellets contain fission fragments and they contain radioactive material that might otherwise be released for a different technology. So we still are excited about Gen 3 Plus, but one of the attributes of these advanced reactor concepts is for communities let's just take military communities as an example. We've seen an increased interest from Air Force and the Army for these walk-away safe, enhanced safety design features that these companies offer. So I think the answer is these technologies really lend themselves to actually provide less pressure on the local municipalities. On the flip side, I do think that our And the incident response side of a nuclear accident does not live within the Office of Nuclear Energy. And so if you're actually interested, I'm happy to then connect you to the folks that are in the Department of Energy that are really responsible for working with state, local, and tribal delegates on the ground in the case of a nuclear hazard, whether it's reactor related, whether it's a source or any other type of incident.
I think we're just about wrapped up there. So thank you very much, Dr. Bahran. Exciting to hear about all the movement that's happening in this area. I'll give one last look out if there's any more questions from the participants. Okay, just a reminder, this is recorded, so the meeting will be on the show up on the YouTube page here shortly. Next meeting is scheduled for July 28th, and I believe we'll be hearing from Oklo. And then TBD for the August. So thank you very much, everybody. Look forward to seeing you at the next one.